So we're going to talk today about rewriting equations of both parallel and perpendicular lines. So let's get ourselves started. So there are three different ways that you can write a linear equation. Linear just means a line. There are three different ways, but we're going to focus on just two of them. And these two are probably the two that you remember. The first one's called slope-intercept form. The second one is called standard form. Ryan's already raising his hand because he remembers slope-intercept form. What is it, Ryan? Oh, slope-intercept. Yeah, good. Y equals mx plus b. Remember this? Yeah, okay, good. Lie to me even if you don't. True. This is very true. So there are two parts to it, the m and the b. What does the m stand for? The what? Growth rate. Ooh, look at you. Growth rate. There's another name for that, though. Slope. The slope. You are correct, though. Yes. You are correct. Wow. I wasn't expecting that answer. What about the B? It's your starting point. Yes. It's also where your graph crosses which one? Which axis? The y-axis. It's called the y-intercept. That means just where it crosses the y-axis. Hence, why this is called slope-intercept form is because I give you the slope and the intercept. Wild, wild. Now, slope, you might have heard other terms for it, right? Growth rate is one of them that you might have heard before. The other way you might have seen slope is rise over run. Yeah, is that bringing back some memories? You hate this? Is that what you said? Oh. Oh, gotta remember this. Okay. Rise over run, which means rise goes which way? You're rising. Up, right? So rising means go up or down first. And then the run is if you go to the right or to the left, if you're moving right up. Now remember, if you're going up, or to the right, that's positive. If you're going down and to the left, that's going to be negative. In Geo, what we're going to use, I don't know if you've seen this one before. Instead of using rise over run, I call it, or we call it, excuse me, the change of y over the change of x. Have you seen it like that before? Some of you have, a few of you. Okay, that's okay. It essentially means the same thing. It means how is your y-axis changing? How much are you moving? And what about your x-axis? How much are you moving as well? It's the same thing. All right, all of these are essentially like synonyms for the same thing. Y-intercept, like we said, is just where it crosses the y-axis. So in the four examples there, we're going to write the equations in slope-intercept form for each one. Now, first thing I want you to do is just label your x and y axis. Which one's your x axis? Show me with your hands. Is it this way or this way? Which one's the x? Good, 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 good. This one's the x. There's half the battle right there. Do you know your axis? Okay, now, for the graph, when we read, we always go from left to right like we're reading a book, okay? So if I look at this graph here, if I'm going from the left to the right, okay, I'm going, which way is my slope going? Is it a positive slope or is this a negative slope? This is a positive slope, yeah. So think about if you're going from left to right, here's Miss Damaso down here. She's walking up a hill, that's a positive slope. Okay. Now, most of the times when I give you slope, I'll pretty much give you the 2 points that I want you to use to find the slope, okay, because I try to be nice about it so that it's like right on the line for you. And all we're going to do for slope is we're just going to count. How many do we go up and how many do we go over? That's it. So if you're going from the left to the right, first part is the rise. How much are you going up or down? So count them. 4. And you're going up, so it's a positive 4. So my slope is a positive 4 over, how many do you go over? 2. And if you're going to the right, is that positive or negative? Positive. So it's 4 over 2. Now, I can reduce that. I can make that smaller. What can I reduce that to be? Yeah, so you can put 2 over 1 or 2. Either one's fine. I'm just going to put the 2. Okay, and then the last part is the y-intercept. So that means where does your graph cross the y-axis? I'm going to highlight. Here's my y-axis. Okay, at what number does your line cross that axis? Right? -3. Good. So when you go to write this equation, you're going to write it as y equals, your slope is 2x, plus your y-intercept, but my y-intercept is negative. So you can either put plus a -3, or you can just put -3 is fine as well. And there's your slope. Or your slope, excuse me. There's your equation. And look at that. You just wrote the equation of a line at slope-intercept corner. Do you feel like you could do 2 through 4 for me? I believe in you. I believe in you. Work with people at your table. Try 2 through 4. I'm going to give you a few minutes to do that one. Or those 4.
I have a question.
Mm-hmm.
The second one.
Yeah.
So it goes over, like on the x-axis, 5, and down 4.
Yep.
Do we have to turn that into a decimal?
No. Always leave it as a fraction. Anytime you're working on a graph, leave it as a fraction.
Okay.
Fractions are your friend when it comes to graphs. So it's where it crosses the y-axis, or whatever number you got. It is right. It is, but keep it as a fraction. Just keep it as a fraction.
So what is that remaining answer? The fraction or the
No, the
that?
whole equation is y equals.
So you want the equation? Because I know, like, sometimes so we always have to figure out the fraction or the equation.
I want you to do the whole thing.
Then we do both things. Both things.
It is negative. So it's because you're going, the rise is you're going from the left to right, you're going down. So your slope should be negative. Well, your slope is what? So you're flip-flopping basically. This is your slope. No, so it'd be y equals whatever your slope is. What? Well, so it was from this point to this point, like down 1, and then remember how many? Right, so your slope is down 1, which is a -1, and then over 3, which is a +3. There you go, that's your slope. So now when you go to write your equation, y equals, there's your slope, -1/3 x, and then plus your y-intercept, where do you at 0? You put plus 0.
How do you get 0.3? How do you use this?
Leave it as a fraction. Leave it as a fraction.
That's not a fraction. Did you do that?
Yes, but you're going down 4, right? You're going from left to right. So you're going down 4 is a negative 4. So think about it, this math is if you're reading a book, you're going down a hill. So this needs to be a negative 4. You're going down. Yes.
On this side, I need to figure out my flow, bro. I think I love the numbers.
You reduce it though. Negative 2 by negative 4. All right, let's take a look at them. Okay, so as we're going through here, here's what I'm noticing. I'm noticing a couple people like flip-flopping the slope and the intercept, right? Rewriting them. First of all, in number 2, okay, if you're reading from left to right, okay, here I am on the left. Here's Miss Matzo. If I follow this line, am I going up a hill or down a hill? I'm going down a hill. That means my slope has to be negative. So when I write my slope, there needs to be a negative number in there. Now, if I'm going from here to here, the first part is rise over run. So I'm going down. How many are you going down? Down. Going down 4, so that's a negative 4. How many am I going over? And I'm going to the right, so it's a positive 5. So there's your slope, negative 4 over 5. At what point do you cross the y-axis? At what number? Negative 2, good. So when you go to write the final equation, it's y equals negative 4/5 x, there's my slope, minus 2. There's the full equation. So if you're going down a hill, your equation better have a negative sign in it. If you're going up a hill, they better both be positive. Negative 2 is, if you look at this line right here, the yellow line, my line here crosses the yellow at negative 2. That's where this negative 2 comes from. Yeah. So let's try the next one. Number 3. Am I going up a hill or down a hill? I'm going down a hill. So here's my point. Here's my first point. Here's my second point. How many do you go down? I go down 1. How many do I go over? 3. So there's my slope, negative 1 over 3. Leave it as a fraction. You want fractions. This is like the one time in your life you want a fraction because it's really easy to graph when you have a fraction. Okay? What is your y-intercept? 0. Your y-intercept 0. So now, when you go to write this equation, you're going to write it as y equals negative 1 over 3x, and then what? Now, you've got 2 choices. You can put plus 0, or you can just leave it, because plus 0 just means nothing is happening there, right? So you just leave it like that. Okay, last one, number 4. Is this a positive slope or a negative slope? Positive, I'm going up a hill. Okay, how many am I going up? 3, and then, yep, over 3. So what does that become as a slope? That becomes a 1, yeah. Well, I will in a second, yeah. You're jumping ahead of me. What's my y-intercept? 4. Okay, so now when I write the equation, I'm going to put y equals. Now your slope is 1, so you can put 1x if you want. However, in a test, you're not going to see the 1. You have to realize that the 1 is there. So my slope is 1, and then my intercept is 4. So my equation is y equals x plus 4. Let's go. How'd you do? Yes. Yeah, 1.
So in a sense, will we have to write it out ourselves, or will it be, because like, I know we do some tests online, and now we do some tests on paper.
Yeah, so like the actual final, I don't know. For me,
For us, it was online.
yeah, I know, but I don't know how they're going to ask you the question,
Oh,
is what
okay.
I'm saying, because I'm not allowed to look at it, so I don't really know. My assumption is they would probably give you equations, and you would probably have to choose like a multiple choice, would be my guess.
So it'll already be written. And
Probably.
Figure it out.
Yeah.
Okay.
Yeah.
I have a theoretical question.
Oh gosh.
So,
All right.
What if the line was just flat? Would there not be an x value?
If it was just
If
this
it was
way
just flat, yeah.
or this way? Oh my gosh, we're going to talk about that in about 4 minutes when we get to the back. That's a great question. I'm going to have you put a pin in it, and we're going to come back to that question. That's a beautiful question. I'm glad you asked it. You're just jumping ahead of me. It just means there's not a slope. That's all that it means. Okay, next part, standard form. Now, standard form is written a little bit differently, and it looks like this. I have a feeling you probably remember it. AX plus BY equals C. Have you seen that before? You actually probably have seen it and just not realized it was standard form. Look, don't let it trip you up. The A, the B, and the C are just numbers. They're just numbers, okay? We write A, B, and C to stand for like they're each their own individual number, but they're just numbers. Okay, you've seen an equation written like that before. Now, this form does not give you the slope. So if I asked you to graph this, like graph an equation in standard form, it would be pretty much impossible to do because you don't have the slope. Right? So what we have to do is we have to rewrite the equations from this form to look like this form. I have to rewrite them to look like this one. So that's what we're going to do. It's okay. It's way easier than you think. It's okay. I promise. It's easy. So let's take a look at number 5. My equation says x plus y equals 6. I want to rewrite this equation so that it looks like y equals mx plus b. In other words, I want to rewrite it so that the y is all by itself on the left. That's all I'm trying to do is get the y alone. So we're going to move everything that's not a y to the other side. That's all we're going to do. Okay, so number 5, take a look. Here's my equation. Put a line down your equal sign. You got 2 sides to the equation. I've got x plus y on the left and 6 on the right. I want to get the y to be alone. So what will I have to move so that the y can be alone? The x. Okay, now. Yeah, exactly. This is just like a regular algebra problem. I'm going to take that x and move it over by subtracting it. Minus x. Whatever I do on one side of the equation, I better do the other. Okay, now watch. Here's what happens. My x's cancel. I've got y equals. Now, yeah, it's literally 6 minus x. However, I'm going to put the x first because the form has the x value first. So my x value is negative x. And then my 6 is a positive 6, so I put plus 6. Ta-da, there's your new equation. So they don't combine together. You're just essentially moving. You're just pushing things over to the other side is all you're doing. That's it. Just pushing it over to the other side. And there's your equation. Y equals negative x plus x. You could graph that now. That's easier than you think. Let's try 6.
Wait, that's it?
That was it. That was the whole thing. There's your equation. Ta-da, that's your equation. That's all I'm looking for. So let's try 6, and then you're going to do 7 and 8. All right. Number 6. Again, I want to get it into the form y equals mx plus b, so I want the y to be all alone. What should I move? The 5x. How are you going to move that over to the other side? Beautiful. Okay. On both sides. Look at you guys. Look at you go. Oh my gosh, look at you. 2y equals. Now I can't put these together, right? One's got an x and one doesn't. So I'm just going to rewrite them, and I want to put the x value first. Negative 5x minus 2.
And then we have to divide everything by 2.
Why? Why?
To get the y alone.
Okay, so the y's not alone just yet. It's almost alone, but this is 2 times y. And I want to get rid of the 2 like I will with any other algebra problem, so I'm going to divide by 2. But now, whatever you do to one side of the equation, you have to do to the other, but you have to do to every piece of the other equation. So I would divide this piece by 2, and I'm going to divide this piece by 2, both of them. Now, you can make it as one big 2 if you want, but I like to do it this way because that reminds me to divide every number by 2. So now watch what's going to happen. On the left, cancels. I get y equals. Now, I told you, leave it as fractions. Can you divide negative 5 by 2 and get a good number? No, you're going to get a decimal. So here's what we're going to do. We're going to literally leave it as negative 5 over 2. Because that means go down 5, go to the right 2. Fractions are good here. It's just telling you which way to move. And then what is negative 2 divided by 2? Oh, negative 1. And there's your equation. So fractions are fine. You want a fraction, actually. You literally want, this is like the one time in your life you want a fraction. Okay? Try number 7 and 8. You try them, we'll check them. 7 and 8. I believe in you. I've already done that. Oh, shoot. Okay. Try it quickly. Depends on how far we get in the next few minutes. I'm hoping not. Yes. Take one more minute. Well, what if it's a negative? What number is really there? It's a negative 1. So how do you get rid of the negative 1? If it was a negative 2, you would divide it by the negative 2, right? Same thing with the negative 1. You still got to divide by it. All right, number 7's on the board. I didn't finish it because I wanted to just show you what happens here. So I moved my 2x over to the other side by subtracting. I got negative 4y equals negative 2x plus 28, and then I divided everything by negative 4. I actually haven't finished it yet, but I was just showing you where I got. Are we okay there? Thumbs up, thumbs down. All right, so the only part that's different here is what happens when you go to cancel them out. Negative 4 divided by negative 4 will cancel, and you get y equals. Now, what is negative 2 divided by negative 4? 0.5, which is what? 1/2. Yeah, it's half. So you can put it as 0.5, but I'm going to leave it as 1/2. Again, I told you, fractions are good. That means you go up 1 over 2. X. And then what's 28 divided by negative 4? Negative 7. Good. Okay, perfecto. Good. We gotta hustle. Okay, number 8. You subtracted 3x from both sides. You got negative y equals negative 3x plus 5, but now my y is still not alone yet. What do I have to do? Divide it by what? Negative 1. Good. So essentially everything's just going to change signs. Y equals negative 3 divided by negative 1 is just 3x, and then positive 5 divided by negative 1 is negative 5. Okay, so I'm just changing signs. All right, flip it over to the back. We're going to hustle really quickly on the back. Okay, I lied, Ryan. We're going to have to do that one tomorrow. Because I'm sorry. Because I want to do this part first, and then we'll get to that. All right, very quickly. Why are we cleaning up? We have 10 more minutes. We're gonna rush through here, bro. Stop. We got 10 minutes. Calm down. No, we got 10 minutes, but I want time for us to work here. Okay. Parallel and perpendicular lines. Now, parallel lines. Here's the symbol for parallel lines. They literally look like two parallel lines. Okay. Parallel lines have the exact same slope. Put that in all caps. Exact same slopes. Literally have to be exactly the same. So the sign has to be the same. The fraction has to be the same. Everything has to look exactly the same. Parallel lines are coplanar, which means they're on the same plane, on the same flat piece of paper. And parallel lines will never, ever what? Touch, intersect, and do not intersect. Okay, so parallel lines have the exact same slopes. Perpendicular lines, so parallel looks like this. Everybody look at me. Parallel. Perpendicular looks like this. Makes a T. Parallel, perpendicular. Perpendicular lines have something called opposite sign and reciprocal slopes. Reciprocals. Anybody heard that word before?
No.
A few of us, okay. Opposite sign and reciprocal slopes. I'll show you what that means in a second. Perpendicular lines are also coplanar. So again, they're on the same flat piece of paper. And they intersect and create what kind of angles? What kind of angles look like a T? Yes, but like what degree measure? Right angles, 90 degrees, yes. So they will intersect at 90 degrees. Okay, so an opposite sign and reciprocal slope means this. One of the slopes is positive. One of the slopes is negative. That's an opposite sign. Reciprocal means the fraction trades places. So here's what that looks like. Perpendicular lines looks like an upside down T here. If one of your slopes is 4/5, excuse me, the reciprocal is flipped 5/4, and then the sign changes. So this is a positive, so my flip sign would be -5/4. Those would be considered reciprocal opposite slopes. So now, using that idea, so it's just in general, the whole thing is negative. So if you've got one negative sign, that's saying the whole thing is a negative slope. So one's going up, one's going down. So we're going to compare the equations, and we're going to determine if the equations are parallel, if they are perpendicular, or if they are neither. So let's watch how easy this is about to be. Number one, all you have to do is identify the slope for each problem. So in my number one, I've got y equals 5x plus 2. What part of that is the slope? Just the 5. Here's the slope. So my m value, my slope is 5. What is your slope in the second equation? Y equals 5x minus 1. Here's your second equation. What's the slope?
5.
5. Okay. Are those slopes the same or are they opposite reciprocals? They're the same. So what kind of lines are these? Parallel lines. So if I went to go graph them, they would both have the same slope and they would just never intersect. These are parallel. You can write the word or you can write the sign. I don't care. This is the sign.
Yeah.
Okay, that's it. That was it. That was it. Nothing. Wait, what? That's it. All you have to do is identify the slope. That's it. Number 2. What is the slope in the first equation? Negative 3 over 2. What is the slope in the second equation? 2 over 3. Circle them. Get in the habit of it. Are these slopes the same? No. Are they opposite reciprocals? Yes. So what kind of lines are they? Perpendicular. You can either put the sign, which is an upside down T, or you can actually write the word. I don't care. Okay, we feeling okay? Right? Not bad. Let's do one tricky one. Number 3. Now, what do you notice about number 3? Oh, come on. What did Mr. Massa do at number 3? Oh, gosh. I gave it to you in standard form. You got to rewrite it in slope-intercept form, which is why we did that on the front. That's why, hence why we practiced that, Wild. That's why we did it. Oh, is it mean, though, or is it just I want you to, like, have a really great education? Which one is it? All right, so let's look at the first one right here. Because we're going to finish this one, and that'll be it. All right. I want to get the y by itself, so what should I do first? Minus the x. Good. Minus the x. I've got 2y equals negative x plus 2. And then what do I have to do with the y by itself? Yeah. Divide every single thing by 2. Divide by 2, divide by 2, divide by 2. Okay. I get y equals, now there's no number in front of the x. What can I put there? A 1. So this is a negative 1/2 x. And then what's 2 divided by 2? 1. Okay, what is my slope of that equation now? Negative 1 over 2. Great, there's my slope. Now we got to do the same thing for the second equation. I'm going to write it over here because I ran out of space. Okay, same thing. What should I do to get the y by itself? Subtract the 6x. Good. I get negative 3y equals what? Good. Negative 6x plus 21. Okay. Now I still get the y by itself, so what should I do? Good. Divide everything by negative 3. Okay. So I get y equals, I know I'm going quickly, I'm sorry. What is negative 6 divided by negative 3? Positive 2. So this is 2x. And what is 21 divided by negative 3? Negative 7. Okay. What is my slope of this problem? 2. Now, are these slopes the same? No. Are those the same? Heck no. Are they opposite reciprocals? Yes. Why? Good. Everyone's got it. The 2 you can really put over a 1, right? So 1/2, you flip it, becomes 2 over 1. This one's negative. This one's positive. What kind of lines are these? No other one, man.
Perpendicular.
Perpendicular because they're opposite reciprocals. Now, we've got 2 minutes left here. I'm sorry. I know I went to the end here. I would like you to do 4, 5, and 6. I know. 4, 5, and 6.
Right now in class?
No, obviously at home because we don't have enough time. We're going to check those tomorrow, okay? Tomorrow we're going to do a practice with it. Probably bring your computers tomorrow if you have them. Okay? You guys did awesome today. Thank you for working to the end of the period with me. I appreciate that. You're welcome. Next time, what kind of phone is that one? Oh, it's 6. Okay, never mind. Because this thing like charges phones, but I think it only works for like 10 and above. But my apologies. All right, let's stop recording. Okay, do those 3 problems tonight, please. 4